Hello students, welcome to the next module on production technology or manufacturing technology, and that's module 2. In this module we will be having about 3 or 4 different parts, like module 2 part 1, module 2 part 2, like that. And in these coming 3 or 4 different parts we will cover the forming process, which is rolling. So in previous lectures we have seen that metal forming process is of about 4 different types. So those 4 different types are rolling, forging, extrusion and drawing. So we'll start from rolling. So today we will see what is rolling and what is hot and cold rolling. So when it comes to rolling or whether forging or any another process, there will be always two types, hot and cold. So hot working and cold working. So that type will be there. So in rolling we will see what is hot rolling and what is cold rolling. So let's start the lecture. So if you come to the basic definition of the rolling, then it is defined as the process of plastically deforming a metal by passing it between rolls. So क्या होता है, दो रोलर रहेंगे, जैसे कि मैंने पिछली क्लास में भी बताया था, दो रोलर रहेंगे, उन दोनों रोलर्स के बीच में कुछ टॉलरेंस रखा जाएगा, कुछ थोड़ा गैप रखा जाएगा. उस गैप में से आपको एक मेटल शीट को जिसको आपको डिफॉर्म करना है या जिसका फॉर्मिंग आपको करना है, उस मेटल शीट को आप उसमें से पास करोगे, and then you will get the desired dimension or desired thickness of the sheet. तो इस प्रोसेस को हम कहते हैं रोलिंग. अब यहाँ पर जो शीट जो आप पास कर रहे हैं रोलर्स के बीच से, वो यदि रिक्रिस्टलाइजेशन टेम्परेचर के बियॉन्ड हीटेड है, उससे ज़्यादा यदि उसका टेम्परेचर है, तो उसको हम कहेंगे हॉट रोलिंग प्रोसेस, और यदि उससे कम है तो वो होगा cold rolling process. So rolling process is most widely used, high production rate, and you will get very close tolerance. Now friction between rollers, that plays a very important role here. So the friction between the rollers and the metal surface produces high compressive stress. So this is very important question from exam point of view. So in exams they will ask, in rolling process what type of stress will be there. So that answer will be, it will be a pure compressive stress, or it will be biaxial compressive stress. So, and unless it is mentioned that the process is cold rolling, you have to take or you have to consider it as a hot rolling. सो आपको हमेशा हॉट रोलिंग ही मानना है जब तक कुछ लिखा हुआ नहीं हो क्वेश्चन में. और यदि क्वेश्चन में इटसेल्फ वो मेंशन कर देता है कि कोल्ड रोलिंग है, तो आपको कोल्ड रोलिंग के लिए उसको फिर स्टडी करना है या उसका आंसर जो है कोल्ड रोलिंग के लिए करना है. लेकिन कुछ भी मेंशन नहीं है या हॉट रोलिंग मेंशन है, दोनों ही केस में आपको हॉट रोलिंग ही उसको मानना है. नाउ लेट अस सी दिस क्वेश्चन. In a rolling process, the state of stress of the material undergoing deformation is. सो अभी भी हमने देखा कि ये वही चीज़ पहुंच रहा है कि रोलर्स के बीच में जब आप किसी मटेरियल को डिफॉर्म करते हैं तो उसमें किस तरह का स्ट्रेसेस प्रोड्यूस होता है. सो व्हाट इज द आंसर? आंसर मस्ट बी ऑप्शन ए, इट इज प्योर कंप्रेसिव स्ट्रेस. नाउ लुक एट दिस डायग्राम. So here you can understand like what is rolling process. So here we are having two rollers. If number of rollers is more, then that kind of rolling is also a rolling process only, but that will have some different name like planetary rolling or meal rolling, like that. So here we are having only two rollers. So from this side, strip will enter into or between the rollers, and this is the exit. So you can see that the thickness of the sheet is reduced here. Now we will, at the end of this lecture, at the end of this module, we will see the formulas also in rolling. What are the different formulas? Now look at this picture. You will have some basic idea of what is rolling process. So from slabs, from blooms, and from billets, what are the different processes and what are the different products that we can obtain by rolling? So from slabs you can get the plates or scalp, or you can also get the pipe and tubes. So by bending the foil or sheet, you can see here, by bending the sheet you can get the seamless tube also. And in case of blooms, you can get the rail and structural shapes and strips, tube rounds and tin plates and seamless pipes. So more or less this process and this process both are same. We will see in detail in coming lectures. And now from billets, again from billets we can get different kind of bars or wire rods or roll of wires. So such kind of products we can get. Now we'll see all these in details. So let's see first, or let us recapitulate what we have studied in previous lectures, like what is hot rolling and what is cold rolling. So very quickly, hot rolling is done above the recrystallization temperature and we'll get fine grain structure, surface quality and final dimensions are not as much cold working process, not accurate as much cold working process. Breakdown of ingots into bloom and billets, that we have also seen, like how we will get blooms and billets by hot working on ingot. And generally hot rolling is done about 50 to 100 degrees centigrade above the recrystallization temperature. Now how the grains or grain structure will change in case of hot rolling. So remember, this is hot rolling. So in case of hot rolling, how the grain size will change. So look at here, let me explain in detail. Initially our grains were like this, circular in cross section ideally. So this kind of grains we are having before this line. Now from this line to this line, in this range we are having our elongated grains like this because of the rolling. Now as this process is of hot rolling process, what happens with these grains after this range or after some time? They starts regaining its original physical properties, and that process is known as recovery. So recovery phase starts like this. So in recovery phase, we will retain back our physical properties without any change in mechanical properties. And after, again after some time, let's after this stage, we'll have recrystallization. So recrystallization means again we will get our grains in the form of grains like this. So inside this only grains will start forming like this. Okay, so we'll get grains like this. And in at the end, that is the third phase of annealing, that is grain growth. So in grain growth we will get like these grains will get combined and one big grains will be there. So there will be growth in the size of the grains. So in nutshell, I can tell you that after the deformation of the grains, as the process is hot working process, there will be automatically annealing process followed by the rolling process. So in annealing we have total 3 different stages, and those are, first one is recovery. So first stage is of the annealing, first stage is recovery, and second one is recrystallization, and third one is grain growth. So that all these 3 steps will followed after the rolling process. Now coming to cold rolling, it is done below the recrystallization temperature, and different products that we generally make using cold rolling are sheets, strips, foils, aluminum foil, etc., with a good surface finish that we already know. In case of cold rolling, surface finish will be good, as well as clothes tolerance will be there. So clothes product dimension. And generally cold rolling is performed on cluster type rolling mills or for high rollers, because high force is required. So rollers will be like this. These are the 2 rollers. Let us see that this is our strip. Now here another roller will be there, and here another roller will be there, just to give support to these rollers. So to give the support to these rollers, we have used to another rollers. Those are these rollers. Okay, so let's assume this is the axis. So this roller will give the support to the inner rollers. As more force is required, so bending may takes place. To avoid that bending, we have used some another rollers. So this is known as for high rolling process. Now let us see the grain structure in case of cold rolling. Obviously, due to rolling, we will be having elongated grains. Like here, grains are like this, but here we are having grains like this. But now onwards, grains will be like this only. There will not be any change in the grain structure until and unless we do the heating. So we have seen in the previous lectures, like to do more cold working, we need annealing. So if I ask you, like if I add 2 more rollers here, okay, if I add 2 more rollers, and if I want to reduce the size of this sheet to this much level, if I want to reduce the thickness to this level, then this is not possible. Probably this is not possible until and unless we do the annealing here. Why it is not possible? Because we are having the deformed grains here, and if you further deform them, then fracture will take place. So it will not allow more cold working. So if you want to do more cold working, then you have to do the annealing here, which results in recovery, then recrystallization and grain growth. Finally, we are getting the grains like this here. Okay, with improved ductility and decreased hardness. So as the ductility improved, now we are allowed to have more some cold working on this. Is it clear? So this is how grains change in case of cold working. Now look at this question. This is something slightly different from what we have studied till now. So which of the following process would produce strongest component? So let us leave this question here, because answer of this question is, if you want to remember, answer of this question is forging. So out of four process, those are rolling, extrusion, drawing and forging. Always remember, forging gives the strongest component. Now these are some different kinds of rolling process. So let me check the duration of the lecture once. So it's already 15-16 minutes. So we'll stop here and then we'll continue in next lecture from here. Okay, so see you in the next lecture. Thank you. Have a good day.